In this video, we are going to study exogeneity with Wu-Hausman and Sargan Test in Python using Spyder IDE. As you can see at the bottom of the screen, this is an educational video only, and no professional advice is included within it. Okay, so let's go into Spyder IDE. So the first step within the video is we need to import the corresponding packages. Therefore, we comment this as step 1, which is packages. And we are going to import statsmodels.api as sm. We're importing that feature from statsmodels for data downloading. Then we're going to import statsmodels.formula.api as smf. We're importing that feature from statsmodels for multiple linear regression calculation. And last, we're going to import linear models.ib.model as lm. We're importing that feature from linear models for two-stage least squares, Wu-Hausman and Sargan tests. To run these code lines, we go ahead, select them, and then we can either click the run selection button or we can press F9 on the keyboard. Then we continue with step number 2, which is data. For data, we're going to create an object named house prices underscore object, which is equal to, and here we're using sm feature from statsmodels.datasets.get underscore r dataset, and we open parentheses. First parameter, which is data name, equals to, within quotations we have house prices, comma, at the following row we have package, equals to, within quotations aer, comma, cache equals to true. So what we're doing here is the following. We're downloading house prices object from our package aer, and with cache equals to true means that once we download the data, it saves it locally, so we don't need to go and download it again every time we run the code. Notice that this will download data and documentation within house prices object. Therefore, we're going to create a new object named house prices with only the data, therefore equals to house prices underscore object, and we're going to get its .data attribute. So to run these code lines, we go ahead, select them, and then we're going to press F9 on the keyboard directly. And if we go into the variable explorer, we see that the two objects have been created. House prices with only the data, house prices underscore object with data and documentation. So regarding the one that only has data, if we double click on any of these cells, we can see the data. And specifically in this video, we're going to focus on the following columns. First at price, which is our dependent or explained variable, then as independent or explanatory variables, lot size and bedrooms. And then as instrumental variables, we're going to have driveway together with, and here at the end, we have garage. Garage, which is the number of garage places. If you have any questions regarding this data, you can read its documentation with the following code line, which is print, and within parentheses we have house prices underscore object, and we're going to get its .2 underscores doc, 2 underscores attribute. So to run this code line, we press F9 on the keyboard, and right here within the console we can see the documentation. So if we scroll up, we can see that we have right here house prices are documentation. So now we can continue with step number 3, which is the model. For this, we're going to create an object named MLR1, which stands for multiple linear regression 1, and it is equal to smf feature from statsmodels.ols function, which is ordinary least squares, and within it we have the following parameters, which are formula equals to, within quotations, because it is a string, we have price as the dependent or explained variable. Special character means being explained by the independent or explanatory variables of lot size plus bedrooms, comma, and we continue at the following row with data equals to the house prices object, the one that only includes data, and we fit this regression, open and close parentheses. So to run these code lines, we go ahead, select them, and then we press F9 on the keyboard directly. And then we continue with step number 4, which is exogeneity. And for this, we're going to continue with two stage least squares And for this, we need to create a new object named mDataC, which is the model data together with a constant or intercept column. Therefore, it is equal to, and here we'll be using SM feature from stats models dot add underscore constant. And within it, we have the following parameters, which are data equals to house prices object, comma prepend equals to false, so that this column of constant or intercept is added at the end. And now that we have this ready, we can continue with the following code line, in which we're going to create an object named MLR2, which stands for multiple linear regression 2, and it is equal to, and here we're using LM feature from linear models dot IB to SLS, which stands for instrumental variables two-stage least squares function, and within it the following parameters, which are dependent variable equals to mData C object. We're going to select its price column, comma, and at the following row we have EXOG, which is the exogenous explanatory variable, because as it is assumed not correlated with MLR1 model error term, therefore equals to, and here we have mData C object with double brackets, we have CONST, which is a constant, and then we have bedrooms, comma, and at the following row we have ENDOG, and that is the endogenous explanatory variable because it is assumed correlated with MLR1 model error term. Therefore, from mData C object, we're going to select lot size column, comma, and at the following row we have instruments, which are the instrumental variables, and from mData C object with double brackets, we're going to select driveway together with garage, which is the number of garage places. And we go ahead and fit this regression with the following parameters, which are COV underscore type, covariance estimation type, homoskedastic, comma, debiased equals to true, so that the covariance estimator is adjusted for degrees of freedom. So two important observations regarding two-stage least squares is that doing two-stage least squares manually using OLS function would estimate correct coefficients but incorrect standard errors and incorrect F statistic. Also, as we can see in this example, we are assuming that within this two-stage least squares that MLR2 model errors are assumed homoskedastic or with constant variance. So to run this code lines, we go ahead, select them, and then we're going to press F9 on the keyboard directly. And then we're going to continue first the following code line with Wu-Hausman tests. And for this, we're going to do so with print, and from MLR2 object, we get .wu underscore Hausmann, open and close parenthesis, and below we're going to print MLR2 R2 dot Wooldridge underscore regression. So to run this code lines, we go ahead, select them, and then we press F9 on the keyboard. And we can see the results being printed right here within the console. So first, above, we have Wu-Hausman original test with an F probability distribution instead of a chi-square probability distribution. And below, we have Wu-Hausman with Wooldridge auxiliary regression test with a chi-square probability distribution instead of an F probability distribution. So specifically focusing on the second one, the Wu-Hausman test with Wooldridge auxiliary regression, we have a joint null hypothesis of one coefficient that stage 1 regression residuals coefficient is equal to 0. If rejected, lot size explanatory variable is endogenous because it is assumed correlated with MLR1 model error term. If not rejected, lot size explanatory variable is exogenous because it is assumed not correlated with MLR1 model error term. So now we're going to continue with Sargon test. So we have Sargon over identifying restrictions test. And for this, we are going to continue at the following code line with print, and from MLR2 object, we are going to get .sargan. And to run that code line, we press F9 on the keyboard directly. And we can see right here the results being printed. We have the test statistic and then we have its p-value. And with Sargon test, we have the joint null hypothesis that bedrooms, driveway, garage coefficients are equal to 0. If rejected, driveway and or garage extra instruments are not valid because they are assumed correlated with MLR2 model error term. If not rejected, driveway and or garage extra instruments are valid because they are assumed not correlated with MLR2 model error term. Important observation regarding this Sargon test is that in order to be able to perform the test, we need that the number of instrumental variables is greater than the number of endogenous explanatory variables. Okay, so with this, we finish with the code file, so we can go ahead and save it. And with this, we also finish with this video. Thank you for watching.